Okay, students, so the purpose of this video is to give you some circuit assembly tips as you go about the pulse interval timing experiment. So I just have some of the key components that we'll have here, some of the larger components to integrate into the breadboard here, which of course holds our circuit. I've got the Arduino Uno here. I have the potentiometer here, which is the variable resistor. Of course, if you hold it in your hand, you should be able to turn this knob here. That's the resistance changing across these three leads here. And I have the battery connector that accepts two 9-volt batteries giving us 18 volts, which is what we need to get that Zener diode to break down in reverse. So let me just tell you how the placement should go here, particularly if we're going to sort of talk about this and get it to work. There needs to be some organization on your breadboard. It's never a good idea just to come in and start throwing components in here with wires going everywhere. Although it will look like that likely when they're done, there can be some underlying organization. So the first thing about your breadboard is let's wire them up like we write in the English language. Let's go from left to right. So in other words, we like inputs to come in from the left and sort of outputs to proceed towards the right. Even if one section of the circuit feeds another section of the circuit, let's do that in a left to right manner, okay? So one of the most important things to get going first when you get these circuits going is establish your power. And remember, the way the breadboard works is these rows across the very top here are all connected. So for example, if I just connected this one pin right here to say 10 volts, this entire line here will be at 10 volts, and I can always tap into that whenever I need 10 volts. It is not electrically connected to the row just below it. So this row just below it, say, could be at a different voltage. Likewise for these down here. And just recall that in the main area of the breadboard right here, these vertical rows of looks like 5 holes are all connected, but the connection does not extend over the gap down to here. So let's just keep that in mind as we proceed. And so what we'll do first is we need the 5 volts from the Arduino, and so let's just get that powered into the breadboard. So I'm going to grab some wire, and you can even think of color coding a bit. So I just grabbed a red one here, although you do not have to choose red. And I'm going to push this right into the 5-volt lead on the Arduino, and I'm going to then say connect that right here to the breadboard. So what I'm doing then is I'm connecting the 5 volts from the Arduino right here to this second row, and I'll tell you why the second row in a second. So this entire first top row here, although the second one down here, is going to be at 5 volts. So if I ever need 5 volts, I don't have to cram them all into the one pin on the Arduino. I can use any one of these pins for the 5 volts. Then, of course, voltage is always a two-way street, so we need the ground in there. So I'll go in here and find ground on the Arduino like this, and there's more than one ground, pick either one, and I'm going to connect that basically over to here. So now what I have here is I basically have a breadboard that when the Arduino gets powered on, I'll have 5 volts all across this top row, and 0 volts of ground all the way to this very bottom row. So that's the other thing about the breadboard, is we like to proceed from left to right with our inputs sort of going this way, and we always want the higher voltages towards the top and the lower voltages on the bottom. So there's a lot of ways to do this, but I'm just saying this is a good way to go to keep it organized. So that's the way the Arduino and the 5 volts would be in there. Now, how are we going to get the 18 volts and the voltage division in this circuit? Well, here's what I'd recommend. And I know you're doing this at home, so it isn't the most convenient thing in the world, but I recommend doing this. I'd recommend getting these clip leads that I had you order here, and these need to go on the potentiometer. And the potentiometer leads are kind of close together, so we want to make sure that when we clip things on, they don't touch. So I'll sort of get the potentiometer sort of going electrically like this, and maybe I'll choose the black one over here, okay? So keep in mind, I am using the potentiometer for the way it's supposed to work. I have the red on one extreme pin and black on the other. We're going to leave the middle one unconnected for the moment. So this essentially would put, say, the 18 volts across the whole potentiometer. Okay, we're not quite ready for the 18 volts yet because we have to get the battery connector in, but the way I would do that is just connect them to the other side of these clip leads right here. So I'm going to go right onto here. So I hope you see sort of the convenience of these clip leads. They grab things nice and tightly, and also when they sort of retract in with the wire, they give a bit of protection against these conductors maybe touching each other. So see, when I have it wired in like this with the clip leads, you can see that now the potentiometer is ready for the 18 volts. Okay, so I'll just sort of put the battery side sort of over here for a moment. It's not so important. We'll connect batteries to those, you know, in turn. Okay, so now what we want to do is the potentiometer is ready to behave like a voltage divider now. So I'm going to ultimately have 18 volts here and ground here, and it's this middle one that's going to vary the voltage when I turn the knob here. So it's this middle one that I want to pull over to the breadboard, but I also have to be aware that I've got to get ground going in here too. So what I'll do next is I'll take maybe a yellow clip lead here, and connect that to the center pin of the potentiometer like that. And now this is going to be my 18 volts. And so how am I going to get this on the breadboard? Because all I have is sort of this clip lead over here. Well, what I'll do is I'll just get another piece of my jumper wire here, maybe a yellow piece here. Got a yellow jumper wire here. Just trying to color code things, and I'll connect it like that. And now this end here is, of course, ready to go right into the breadboard. And so I'm going to put that right above the 5 volts for the Arduino like that. Okay, so you can look at the way your breadboard's looking now. The 5 volts for the Arduino will exist all along this second upper row, and this one, the variable voltage coming out of the potentiometer, will exist on this yellow wire and now occupy the entire very top row. So you see I'll have anywhere between 0 and 18 volts on the top row, the 5 volts direct DC from the Arduino here, and the ground all the way down there. And so let's also remember that the potentiometer ground, the black one, has to get tied into the circuit so we have a common ground throughout. So what I'll do for that is use still another clip lead. Maybe this green one here. I'll clip it right onto the black one like that. So whatever ground is coming in from the 18 volt power supply is also going to be, or the two batteries rather, is then going to come off of this clip lead here. And using the same technique, by grabbing this wire on the clip lead, I will now take this green wire and put it on the shared ground with the Arduino, like that. So see, now the Arduino and the battery pack are going to share the ground as they should, and I've got the variable 18 volts and the plus 5 volts just below it. So see, I'm getting kind of organized here. I've got my power sort of going. When the Arduino's powered, we'll be ready, and when I clip the two batteries onto the battery clip, the potentiometer will be ready. And so lastly then, that's looking pretty good so far, so I can be running the circuit, and I can turn this knob here to vary the power on the breadboard. And so the last thing to place then is the integrated circuit. This is the LM311 right here. That is our comparator, which will make our avalanche diode pulses into pulses, TTL pulses that the Arduino can understand. And I'm just going to sort of put that right around here on the breadboard. Just put it right in there. It is meant to span this gap. That way the pins on the top side don't talk to the pins on the bottom side, so you sort of have that going. And now I think you're in pretty good shape. This is sort of how the general components are going to go. And also, these things like the battery pack, you can just sort of just get that far away, because once the batteries are connected, it doesn't really do anything. So just get it out of your way. And these clip leads here should be pretty firm on the potentiometer, so you can just sort of leave that, but you'll be ready to turn this as needed. Now what's next? Well, unless I forget something, I feel like what's next then is, because you know that you have 5 volts right here, you could definitely build that 0.1 volt voltage divider sort of in this region of the board right here. Maybe the resistor will come in here and go into the breadboard right here, the R1 for that voltage divider. The R2 can then go from right below it over to here for the R2, from here to here, and then maybe a connection to ground, or just direct to ground. So maybe the R1 will come out of this pin right here and hit right here, and the R2 will go into this pin and come around and go right to ground here. And that'll be that 0.1 volt voltage divider that you need. And then that center connection point, which is right around here as mentioned, can come over to the comparator in the negative reference for that comparison voltage. So I would imagine then, when all is said and done, you'll have sort of the 0.1 volt voltage divider just sort of sitting right in this region right here. Okay? And how about the diode, the avalanche diode, or the Zener diode rather, and the other resistor? Well, that can probably just be put over here, straddling the integrated circuit itself. So you can take the Zener diode and go into the 18 volts, not the 5 for the Arduino, the 0 to 18, that'll be at the very top. So come into here and right into pin 2 or 3, whichever is the positive reference for the comparator. So this is where the diode will sort of span something like this, and then that 10K resistor will then go from the end of the diode and the connection point to the integrated circuit on over here to ground, something like that. So you can see how your circuit will be built, and this is sort of my recommendation for how to get yourself started.